So, Assalamualaikum, Doctor, and every good day, everyone. So, we are from Group 4, and today we are going to present our case study 2, which is focused on the technology readiness level assessment for a mobile penicillin G and SCLIS for 6-APA productions. So, before we begin, let me briefly introduce I am Nur Shakira binti Muhammad Sharif, followed by Nur Ain Fadila binti Yusof and Nur Nabila binti Zaino. Before discussing the technology readiness level, let me first introduce the technology selected from our case study number 1. Our case study number 1 focused on the production of 6-amino penicillinic acid or 6-APA using the immobile penicillin G acylis known as PGA. 6-APA is an important intermediate used to the manufacture many semi-synthetic penicillin antibiotic such as ampicillin and amoxicillin. In this process, penicillin G acylis catalyst is hydrolyzed of penicillin G to produce the 6-APA and phenyl-lactic acid. Unlike the free enzyme, the enzyme is immobile on the solid support. So this improved enzyme stability allow the repeated use and increase the overall efficiency of the production process. So due to the advantage, immobile PGA has become one of the most widely used biocatalyst technology in the farm. In this slide, an overview of the technology used in our case study. So the biocatalyst used is penicillin G acylis, which is immobile using the covalent immobilization method or glycosid active agar. So this immobilization method create a strong attachment between the enzyme and its support material, so preventing the enzyme leaching while improving the stability and operational lifetime. So the process is carried out in the packed bed reactor where the immobile enzyme remain inside the reactor while the penicillin G solution continuously flow through the catalyst bag. So during the reaction, penicillin G is converted into the 6-APA, which is the desired product, and phenylacetic acid, which is the byproduct. So the continuous process offers several advantages, including the high enzyme stability, enzyme reusability, lower operational cost, is easier to downstream separations, and improve the productivity, and also make it higher suitable for industry manufacturing. So next, we evaluate the technology using the technology readiness level or TRL framework. So based on the evidence gathered from the case study number 1, an industrial application, we classify the technology as TRL9. TRL9 is the highest level technology maturity. It indicates that technology has been fully proven in an operational environment and already been used a larger scale commercial production. So immobile penicillin G acid process certify the level because it's already been adopted by pharmaceutical industry and commercial production of 6-APA. It also demonstrate reliable long-term operation, consistent product quality, and strong economic performance, and make it mature and commercially successful technology. Okay, so this slide explains the justification of assigning TRL9. So first, the technology has been implemented commercially for the producing 6-APA, demonstrating successfully industry deployments. Second, the use of continuous packed bed reactor allow the stable and efficient large-scale production with a higher productivity. And third is covalent immobilizations significantly improve enzyme stability and allow the enzyme to be reused for the multiple production cycle and reducing operation costs. So in addition, the enzymatic process operate under the mild reaction condition, which reduce the energy consumption and minimize the use of hazard chemical. So this make a technology more environment friendly and support sustainability manufacturing. So therefore, the considering its commercial application, technical reliable economy feasibility and environment benefits, and technology fully certified and certified the characteristic of TRL9. So in conclusion, immobilized penicillin G acylase is matured and well-established industry biocatalytic for the production of 6-APA. The combination of covalent enzyme immobilizations and continuous fed-bed reactor technology provide the excellent operational stability, high productivity, and also lower production costs. So furthermore, the process support the sustainability through the enzyme reusability and reduce the environment impact. So based on the technology readiness level framework, we conclude that this technology is classified as TRL9, indicate that it had achieved a fully scaled commercial development and it proven suitable for industry pharmaceutical manufacturing.
Based on the simulated survey responses from 50 respondents, the societal and health aspects indicate a generally positive public perception towards the use of immobilized enzyme technology in antibiotic production. The survey results demonstrate strong public support for the societal benefits of immobilized enzyme technology. For question 4, which assess whether respondents support the use of enzyme technology because it benefits society, the majority of the participants selected agree or strongly agree, while only a small proportion remain neutral or disagreed. This finding suggests that most respondents recognize the potential of enzyme technology to contribute positively to society by promoting more efficient and sustainable pharmaceutical manufacturing. Similar question 5 evaluated respondents' perception of whether enzyme technology could improve the availability of antibiotics for patients. Most respondents expressed agreement, indicating confidence that immobilized enzyme technology can enhance production efficiency and help ensure a more reliable supply of antibiotics. Increased production efficiency may reduce manufacturing costs, shorten production time, and improve accessibility to essential medicines. Particularly during periods of high demand, overall the responses reflect a positive perception that enzyme technology has the potential to strengthen healthcare services and improve public welfare. The health-related responses also indicate a favorable perception of immobilized enzyme technology. In question 6, most respondents agree that using enzymes in antibiotic production can produce safer and higher quality medicine. This reflects public confidence in biocatalytic processes, which are widely recognized for their high specificity and ability to minimize unwanted byproducts during pharmaceutical manufacturing. For question 7, respondents were asked whether enzyme-based manufacturing is a healthy alternative compared with conventional chemical processes. Again, the majority selected agree and strongly agree, suggesting that respondents perceive enzyme technology as a cleaner and more environmentally friendly production method. This perception is consistent with the characteristics of immobilized enzymes, which typically operate under milder reaction conditions, reduce the use of hazardous chemicals, and generate less waste than traditional chemical synthesis methods. Overall, the survey findings indicate that respondents have a positive attitude toward the health benefits of immobilized enzyme technology. The strong level of agreement suggests that the public believes this technology can contribute to producing safer pharmaceuticals while supporting environmentally sustainable manufacturing practices. These positive perceptions may encourage greater public acceptance of enzyme-based pharmaceutical technologies and support future investment in research and industrial implementation.
Assalamualaikum. My name is Nur Ain Fadila. So, as part of our case study 2, we interviewed a registered pharmacist to gain a healthcare professional perspective on our topic, which is the use of immobilized penicillin G acylase in antibiotic production. Pharmacists were chosen because they play an important role in ensuring that medicines are safe, effective, and meet the required quality standard before reaching patients. Their perspective allows us to better understand the importance of medicine quality, patient safety, and public awareness in pharmaceutical manufacturing. In this interview, we asked several questions related to our case study, including the importance of quality control, the benefits of enzyme-based technology, and the public understanding of biotechnology in medicine production. So let's watch the interview to hear the pharmacist's professional insight. So good morning to Puan Najiha. First of all, thank you so much for taking the time to join us today. We really appreciate your willingness to participate in this interview. As part of our case study too, we would like to ask you a few questions about antibiotic manufacturing and enzyme-based technology from your perspective as a registered pharmacist.
Good morning. You're most welcome. Thank you for inviting me. I'm happy to be part of your project and I'll do my best to answer your questions.
Okay, thank you, Puan Najiha. We really appreciate your time. So let's begin with our first question. So, for my first question is, as a pharmacist, how important is it to maintain high quality during antibiotic manufacturing?
Okay, so it's extremely important because antibiotics need to be safe, effective, and consistent before they're given to patients. Any issue during the manufacturing process, such as contamination or poor quality control, can affect the medicine effectiveness and patient safety. That's why pharmaceutical companies follow strict quality control throughout the production process.
Oh, I see. Oh, that's really nice info. Thank you for sharing that. It really highlights how important quality control is in protecting patients. So, moving on to our next question. Our case study focuses on the use of enzyme-based technology in antibiotic production. From your perspective, what are the benefits of using this technology?
Oh, okay. Enzyme-based technology has many advantages because it can produce high-quality antibiotic intermediates more efficiently while reducing unwanted byproducts. When properly controlled, it also supports as a safer and more sustainable manufacturing process without compromising medicine quality.
That is very insightful. It is interesting to know that this technology not only improves production efficiency but also supports sustainability. Okay, now we will move on to our final question. In your opinion, Puan Najiha, do you think the public understand how biotechnology or enzyme-based technology is used in producing medicines?
I think many people are still unfamiliar with it because they only see the final medicine and not how it produced. That's why public education is important. When people understand that enzyme-based technology helps improve medicine quality, safety, and sustainability, they're more likely to trust and accept it.
Yeah, thank you very much for sharing your knowledge and valuable insight with us today. Your explanation has given us a better understanding of the importance of medicine quality, patient safety, and also public awareness in relation to enzyme-based technology for our antibiotic production. We truly appreciate your time and contribution to our project. Thank you so much, for Najiha.
You're most welcome. I'm glad I could help and I hope that your project goes well and I wish you and your group all the best for your presentation.
Okay, so after hearing the pharmacist's perspective, it is clear that developing enzyme-based technology is not only about making the production process more efficient, it is also about making sure the technology is safe, follows regulation, and accepted by society. Firstly, in terms of safety, the manufacturing process must be carefully controlled to maintain enzyme activity, and produce high-quality antibiotic intermediates consistently. Regular maintenance and safety inspections are also important to ensure a safe working environment and reduce operational risk. Secondly, from a legal perspective, pharmaceutical manufacturers are required to comply with GMP, OSH, OSH, and DOE regulations. These standards help ensure medicine quality, protect workers, and minimize environmental impacts. Finally, from a cultural perspective, many people are still unfamiliar with enzyme-based technology. Therefore, public education and transparent communication are important to improve understanding and build confidence in this technology. Overall, the successful implementation of immobilized penicillin GS list technology depends on balancing innovation with safety, legal responsibility, and also the public trust. Engineering is not only about designing efficient manufacturing processes, it is also about making responsible decisions that protect people and the environment. In our case study, engineers play an important role in ensuring that immobilized penicillin GS list is used safely and effectively to produce high-quality antibiotic intermediates. They must make sure the manufacturing process is well controlled so that the medicines produced are safe, reliable, and meet pharmaceutical quality standard. At the same time, engineers have a responsibility to reduce environmental impacts by minimizing waste and following sustainable manufacturing practices. They must also comply with professional ethics, safety regulations, and environmental law throughout the production process. Above all, engineers should always act with honesty, integrity, and accountability. Every decision they make should prioritize patient safety, public welfare, and environmental protection, because these responsibilities are just as important as achieving production efficiency. Okay, corporate social responsibility or CSR is about how a company gives back a society beyond its business operations. In the pharmaceutical industry, producing safe medicines is important, but companies also have a responsibility to make a positive impact on the community and the environment. For example, they can organize public awareness campaigns to educate people about the responsible use of antibiotics and explain the benefits of enzyme-based technology in medicine production. They should also adopt environmentally sustainable practices such as proper waste management and pollution prevention to minimize the environmental impact of pharmaceutical manufacturing. In addition, companies can support education by collaborating with schools and universities through STEM outreach programs, helping students learn more about biotechnology and inspiring future scientists and engineers. Finally, they can contribute to community health by working with healthcare professionals to organize health screening programs and public health awareness activities. These initiatives show that responsible pharmaceutical companies not only focus on producing quality medicines, but also creating long-term benefits for society, the environment, and also the future generations.